Okay, now see here. What are the features of a transformer? Primary resistor and current are small. The same flux links both primary and secondary, as very little flux escapes the core. And the last one is the secondary current is very small. Okay. So if the transformer is very efficient, 100%, okay, then we can use this formula. This formula is used when transformer is 100% efficient. 100% efficient. So 100% efficient means no loss of power. Okay, no energy loss. When there is no energy loss, you can use this formula. Okay, when there is no energy loss, you can use this formula. So what happens? A well-designed transformer has efficiency of 95%. A well-designed transformer. A well-designed transformer has efficiency of 95%. Okay, it has an efficiency of 95%. Is that clear? Is that clear, all of you? So you can use this formula. Okay. Yeah. So is it clear, Mr. Arham? Is it clear, Arham? Okay. So shall we go ahead, Dhruti? Can you take a picture of this and send it?
Yes, sir.
Yes and no? Okay. So we'll go to the next part. The next part is what? Now here, if what happens is if okay, we have to discuss now step up and step down transformer. Okay, in step up transformer, step up transformer, step up transformer, step up transformer. In step up transformer, what will happen now? NS is greater than NP. NS is greater than NP. VS is greater than P. And what will happen? So here the ratio of what? The ratio of NS by NP, NP by NS, NP by NS is less than 1, and IS by IS is less than IP. Is that clear? So in step up transformer, what will happen? NS is greater than NP, VS is greater than VP, NP by NS is less than 1. Okay, so that is happening. Next one is what? NS is for step down transformer. Step down transformer. Where do we use step up transformer? Any idea? Where do we use step up transformer? Yes, any idea where do we use step up transformer?
No, sir, no idea.
At at the grid station. At the grid station where the power is not manufactured. What is it?
Produce.
Yeah, power is produced or electricity is produced. Okay. Where the
So at power plants?
A power plant, yeah, where the energy is produced. At that point, what happens, the power is around 33,000 volts, around something, 33,000. They increase the voltage to 1,33,000 voltage using step-up transformer. Okay, so what happens here is, see here, at the power station, this is the grid. In the grid, the power may be, the voltage here may be 33 kV. So they have to transfer on the power lines. That is said to be high HT towers, high tension towers. So the voltage here is around 133 kilovolt. Okay, the voltage. Why? Again, there is a loss of, when they are transferring on the wires, there is a loss of power. By the time again it reaches the substations, it is only again 33,000 volts. So much of power loss is taking place. So much of power loss is taking place in the at the transfer, or when we are transferring on the lines. Okay, so then again they use the step down transformer. Here they use step up transformer. Here they use step down transformer, and they bring down to 230 voltage for the offices. First they bring down for the big what is it called, industrial. We have big industries, no? We have big scale industries, large small scale industries, then offices. So large scale industries, we like cement factories and all. We need at least 23,000 volts. If it is like small scale industries, they need 10,000 volts something. If it is for offices, only 230 is enough. Okay, so like that, they step down in that way and they bring it to our home. Okay, now so here NS is greater than NS here, NS is less than NP, and VS is less than VP. In that case, what will happen? The number of terms NP by NS will be greater than 1, and current in the secondary will be greater than current in primary. Such type of transformer is known as step down transformer. Such type of transformer is known as step down transformer. So step down transformer we use in the substations. This we use in the substations. This we use at the grid. Okay, this we use at the grid, and this we use at the substations to bring down the power. Okay, to bring down the voltage. Keep this in the mind. You cannot apply this concept on DC current. It is only for alternating current, not for this one. So keep that in the mind. Transformer is completely different from what we studied until now. Okay, the resistor in AC, current in inductor in AC, capacitor in AC, that we are using oscillator. That one, keep that in the mind. That is using oscillator. Okay, we are using power gen, that is frequency generator for that. We use frequency generator and we increase and decrease the frequency. That is a different thing. This is completely wall outlet, the power, the alternating current which is moving in the power lines. Okay, this is about that one. Okay, is this clear?
Yes, sir.
So step down transformer is where exactly is the step down transformer? Is it in the wire?
Have you seen like here SIVA buildings, small buildings will be there in the areas?
Yeah, the rectangular box.
Yeah,
right,
right. In that we have a, if you when they open that, we can see a iron box in that one where three things will be connected. Three wires will be connected like this. I don't know exactly, but I will try to draw. Like we have like this, no? The steel one, and here there will be
yes, sir.
knobs.
I've seen it in India.
Yeah, here like three wires will be there like this. Did you notice this one?
Sir.
Inside that there will be primary and secondary, and there will be oil also. This is the whole setup is kept in the oil. Why? So that the loss should not take place. The flux linkage should not be there. Flux leakage should not be there. For that purpose, we use that. Flux leakage should not be there. For that purpose, we use this one. Okay. So that is completely. So it is in India. What they do, they next to this only they will connect they will have their own shop and all. Yeah, exactly. Yeah, this one. This is a big transformer. See, this is a very big transformer, which is in the power grid. The power, wherever there is a power station, you have these large transformers. Okay.
So this is a step up one.
This is for step up one. The small ones. Okay, yeah. See, this is the small one. This is for the step down transformer, what we have in our areas. Okay. This is now here is not open. Actually, it is somewhere now with the SIVA and DIVA have their own small buildings in the areas. Okay, electricity, they will write that electricity board. Yeah, short electricity. Down there is no one building, small building. Yeah, that one. Yeah, that is a step down transformer. Transformers are fitted in that one. So from the station, it comes to that place. But you cannot see that power line because it is underground. It is underground. So those cables come. So in the high tension towers also directly we cannot, that high tension towers we cannot directly use that wires you cannot bring down to our place. It's not possible. That is very high voltage. Okay, so those wires will go to the substation. From the substation, the power is bring down and then brought down, and then it is given to the industries. First large scale industries, small scale industries, then it comes to the office. Like that, this step down in the sequence. So that is why the industrial area is completely different. If you see the cement factory is somewhere out in the outskirts. Okay, because the voltage supply is something different for that for those cement factory. And now small scale industries will be there. What is that? Like manufacture of what is that? Metals, or manufacture of chairs and all. They have some large small scale industries. Now after that comes to the offices. Okay, that is what sequence. That is why industrial area in any in any city, it is like outskirts. So the voltage required is different. Okay. Now, next one is what? Last one is what? Characteristic of an ideal transformer. How should be an ideal transformer? Okay. Is it clear all of you?
Yes, sir.
Okay.
So are there
Yes,
any
sir.
more differences between step up and step down?
What is that?
Step down? So are there any more differences between step up and step down
No,
transformer?
step down, number of turns, voltage on primary, voltage on secondary. The number of turns, then current. These are the three ways. And the second one is what? Where to be used? This you should know. One is step up is near the grid station, and step down near the thing. And even in our, I will tell you, if you take any LED bulb, have you seen a LED bulb? LED bulb, small
Yes.
LED bulb will be there. In the LED bulb
Yes.
also there is a transformer. If you have a spoiled LED bulb, open that holder very carefully. Open the holder very carefully.
White part is
There will be four things. There will be a small board in that. On the small board, there will be a step down transformer. From step down transformer, there will be four diodes like this. This is a bridge rectifier. Okay, and there will be a small capacitor also here. A capacitor. These are the diodes. These are the capacitor. This is the transformer. From there, the output will be that output will go to the bulb. That is how. See, the 230 voltage is there, no? The 230 voltage AC you cannot directly convert to a DC. This transformer has to convert to DC current. How can we do that? First, the transformer has to bring down. We have to use step down transformer from 230 voltage. We bring down the voltage to 30 volt. From 30 volt, that is given to diodes. From the diodes to filter it, we give it to capacitors. Then after that, the current is converted to DC. The direct current goes to the LED bulbs or LED tube lights. Okay, yeah, very good. Yeah, excellent.
Yes, sir.
Yeah, here, see, you can see this. Just one. See here. See here, when you open the bulb, I think you can see now. Are you able to see
No,
this?
sir, we can't see the entire
Oh,
thing.
so it is reflecting a lot.
Sir, the screen is, I think, too bright. There's a lot of reflection.
No. Maybe.
Sir, his or her phone, there's a lot of brightness, sir. If you can reduce
So
the
there's-
brightness, we can see it easily.
Its brightness is very.
But you cannot see now. Now see, are you able to see now?
No, sir. So it's pretty much the same.
Are you able to see now?
Yes, sir, we can see in one way. Yeah, tell us, sir.
No,
A bit.
something like this. Okay, see in the bulb when you open, you can see there is a here there is a transformer. Okay, you can also go to the just type the transformer. Okay, we can say transformer inside a bulb, just LED lamp. When you open the lamp LED, you have a transformer. There is a capacitor. There are diodes in it. Okay, which is converting alternating current to direct current. ये वाला है कैपेसिटर for filtering इसे डायोड है the blue one ये वाला नहीं ये वाला डायोड है ये वाला कैपेसिटर this is a transformer ये वाला छोटा वाला like that. Okay, so
transformer is connected.
yeah, you can open it. It's not like very expensive. Just if you have a spoiled bulb LED lamp, just open it carefully. You open it. Okay,
Transformer is connected to the screw.
the input voltage voltage है ना वो AC है 250 AC. Then it will convert to DC. First it will bring down first. The transformer will bring down the voltage from 230 to 30 voltage. Then that current goes to diodes and it will filter. The capacitor will filter and give that current to the lamp, LED lamp. Okay. See, it is there. Yeah, that is the thing. यहाँ पे है ना देखो. This is a transformer. I think. ये वाला है ना यहाँ पे transformer है. It goes to the diodes and then it comes diodes and then capacitor then output. It's like will be there. The circuit will be there. The whole circuit will be there. See. There is an IC also for this. This can do the process. The transformer IC will do everything. In that nowadays IC is completely IC is doing that. It has diodes, it has capacitor, everything.
Nice.
Only a transformer and an IC. The IC has all the 4 diodes and the capacitor also. Now it is ready made. Okay, the latest ones. We need to connect all this. Oh yeah, see there are 4 diodes are there
Mm.
like this. 4 diodes, and then this is the IC. What is doing that process? Okay, so we will go ahead now. What are the characteristics of an ideal transformer that we can finish today? So tomorrow there won't be any class. Okay,
Oh,
tomorrow is Sunday, so there is no class. No,
okay, picture.
you didn't take it. I think you sent already.
No, not this side.
Okay.
It's okay.
Leave it. And then characteristic of an ideal transformer. Characteristics of ideal transformer. So characteristic of an ideal transformer. What is that characteristic? Number 1 is what? Flux leakage. Flux leakage. Okay, flux leakage is what can be minimized. Can be minimized. Can be minimized by primary over secondary. Primary over secondary. Flux leakage. Okay, it can be minimized by primary over secondary. Generally in number of turns. It depends on the number of turns. Number 2, that is resistance of the winding. Number 2 is resistance of the winding. Resistance of the winding. So what happens? There will be so many turns in the primary and secondary. It can be minimized by using thick wires. It can be minimized. It can be minimized using thick wires. Instead of using thin wires, use thick wires. Number 3. So we have eddy currents. What are eddy currents? When AC is continuously flowing through the any soft material or soft iron core material, it will get heated up. Okay, that is said to be heating cause. Okay, continuously AC cycle is passing through. That is said to be heating cause. So how can we reduce that? Can be reduced by laminated cores. Can be reduced by. It can be reduced by laminated cores. The laminated means like plastic thing or sometimes turpentine painting on the laminated cores. Use laminated cores. Have you seen lamination on a paper? You have seen the same way on the windings. What we do is we paint it with a thinner. With a thinner, we paint it so that the flux will not go outside, or eddy current can be reduced by that process. Okay. The last one is hysteresis. Okay, magnetic material of low hysteresis. So can be minimized hysteresis loss. Hysteresis loss. What is hysteresis? So can be minimized by magnetic material of low hysteresis. Magnetic material of low hysteresis.
So what is hysteresis?
Hysteresis means this one. This is what B and BH.
Oh, that graph is called hysteresis.
Yeah. This is hysteresis graph. So what happens is, suppose there is example I will give. This is a magnetic material. Okay. You started applying magnetic field so that you can magnetize this material. So what you have to do, there is no north pole, south pole. This is the magnetic material, and you started applying. You started applying the magnetic field in one direction. So what happens? And the whole material will get magnetized. Is it not? You started magnetizing, it gets magnetized. Suddenly remove the magnetism. Will the magnetism will not become zero in that one? There will be still some magnetism left over.
Yes.
This is said to be what? This point is said to be what? X and Y. There are 2 points. What is coercivity and retentivity? This point is said to be retentivity. You know what is retaining? Retain.
Yeah.
Retaining.
So to gain back.
Yeah, retaining means still it is there. Something is there. Okay. So when you suddenly make it zero, it doesn't. The magnetism will not become zero. That is said to be retentivity. Now start applying the magnetic field in the opposite direction. What will happen? Now a magnetization takes place and becomes maximum at this point in the opposite direction. Okay, but what is this point then? This point is X. What is the meaning of this? Even B is 0 when H is not equal to 0. Okay, B is 0. So what happens? It starts becoming in the opposite. There is a point where B will become 0 when H is not equal to 0. That is said to be coercivity, retentivity, coercivity. Now at this point, it will become maximum, but in the opposite direction. Now again, remove this magnetism suddenly. What will happen? Again, there is a point here. It will not become 0, but again retain. Now apply again, start applying magnetic field in the opposite direction. It should have followed this path, but the problem is it is not following the same path. It is following some other path. Got it?
Yeah, sir.
Yes,
It should
sir.
have followed the same path, but it is not following the same path. It is following the other path, and it completes like it completes this. So this is known as hysteresis. Is that clear?
Yes,
Magnetic
Yes, sir.
hysteresis. This is known as magnet. And what is that loss? If you calculate the area under this graph, okay, that is known as. So that is the magnetic loss taking place. That magnetic loss is converted into heat energy. That is said to be hysteresis loss. That is said to be hysteresis loss. So you have to take soft iron core material for this. Soft iron core material, we have this type of graph. If you are saying, if you are taking a hard magnetic material, it will be like this. A hard magnetic material, it will be like this. It will take so long to magnetize, so long to demagnetize. Okay. So what is that area gives?
Yes, sir, got
Area will give the energy. What is that energy? Heat energy. And this is also known as magnetic loss. Okay. It
Okay.
is a
So
magnetic
what's
loss,
his?
or that energy is converted into heat energy. So that is the meaning of hysteresis. Is that clear?
So I didn't understand what's hysteresis properly.
Hysteresis, this curve is known as, the name of this curve is known as hysteresis.
Oh, okay, sir. Okay, sir.
Is this clear, Dhruti?
Yes, sir.
Okay. So this completes your topic. Okay, for today. So tomorrow there is no class. Only again I'm left with the next one. That is the last one. That is AC generator. So tomorrow the day after tomorrow I'll be teaching that. Okay.
Okay, sir.
Yes, sir.
Okay, Dhruti, just wait for a minute. Okay, the class, just one second.
So can I leave? I have to go get
Yeah,
my
yeah, yeah.
PCR.